Hello. Hello and welcome to this video. As I said in my last video, we will study segment trees. So this is going to be only theory. All the slides says implementation. I'll show you code, but we will not run the code and we will not analyze the code in this video. So what are segment trees? That is the question. So segment trees is a special kind of tree which makes it very efficient to make range queries. Okay. Second question is what are its uses? The biggest use of segment tree is in competitive programming. It helps you a lot with problems when you do it. Okay. Now the updates are also very fast. If you look at time complexity, then building is obviously order of n, but time complexity is log n. Okay. Now, how do we structure it? So assume there is an array, okay? And the array has 8 elements, 1, 2, 3, 4, 5, 6, 7, 8. So we start with the full segment, okay? That is from index 0 to index 7. Take the sum and put it in the root node. Then on the left side, we take 0 to 3 and right side 4 to 7. We split the range into two halves and put the sum. So sum of the elements 0, 1, 2, 3 goes on the left side and 4, 5, 6, 7 goes on the right side. So you see, any node will be sum of its children. Okay, so 0, 7 will be the sum of 0, 3 and 4, 7. And then you split again. So left side of 0, 3 becomes the elements 0 and 1 and 2, 3 contains 2, 3. So when you sum 0, 1 and 2, 3, you get 0, 3. And similarly on the right side, 4, 7 is split into two halves, 4, 5 and 6, 7. Okay, so when you combine 4, 5 and 6, 7, you get 4, 7. And then on the leaf nodes, you have all the numbers 0, 1, 2, 3, 4, 5, 6, 7. So that's the kind of structure you're looking for. So the array from which you will build will have these values. You can have any value. Okay, so these are index position of the array 0, 1, 2, 3, 4, 5, 6, 7. Okay, so you can see how a segment tree looks like. Now, although it makes range queries, there is a problem here. The problem is that the space required will be almost twice the number of elements in the array. If you look at this particular structure, you have 8 leaves and then you have 7 extra nodes for holding the sum. But we are going to bear that because it gives us fast range queries. That's the whole purpose of segment trees. Okay. Now, suppose you want to do a query. So we want to query from node 2 to 5. That's what we are going to query. Okay. That is, we want the sum of the nodes from 2 to 5. That's what we want to do. So we start at root node, obviously, because it's essentially a binary tree. And then we explore left, that is 0, 3. And then we explore further. So we get 2, 3. Okay. And we have our node 2, 3 on the left side. It should be on the right side of that. There is something wrong with the diagram. So it is on the right side. This diagram has exchanged the children. This should be right here. 0, 1 will be on the left side. Okay. And then similarly on the right side, we will look at segment 4, 5. Okay. So once we have both the segments, we combine the result. So we get 2 to 5. All right. So that's how you do the query. Now, if you look at this particular structure, then you see that any range you want between 0 to 7, as long as the range is continuous, you can find from this diagram. So now you see when you perform lookup on any binary search tree or any kind of binary tree, the general complexity is order of log n. So obviously, even for this case, the finding the range would be order of log n. So that's how you build and structure the segment tree. Now we want to update something. Okay, so how do we update? So suppose we want to update index 3 as shown in the title over here. So we start at 0, 7, we go to 0, 3, we go to 2, 3, we go to 3. And then we update leaf. So whatever value you want to update, you can update and then you propagate the sum. Okay, so in the recursion, when the tech stack will unwind, you go on updating. So suppose that at position 3, initially we had 5 and then we put 10. So you will increase this sum would be this sum with 5, this sum with 5, and this sum with 5. So propagate till you hit the root node. Okay, so whatever is the difference, you propagate it to root node. Now, implementation we are not going to discuss. I'm showing it just for you to study. Okay. I'm not going to talk about this implementation in today's video. And similarly, you can look at query video. Possibly you can pause the video and type the code, run it, and then we have update. So we have three functions: build, query, and update. And the code is given to you just so that you can analyze the complexity, time complexity of different operations. So I already talked about the complexity. So with that, we come to the end of video. That is the theory of segment trees. In the next video, I'll show you the code and maybe I'll do some complexity analysis on the code. Okay. So thanks a lot for watching the video, and I hope that you have enjoyed this video. So keep programming and keep practicing, and that's how you'll become better. So with this, I will end this video. I'll see you in the next video with the implementation of segment tree, and we will run the build, update, and query. We will do that. So once again, thanks a lot for watching the video. Enjoy.